Okay, so time to learn about exponential growth and decay. There are a few things that we need to be able to do to be successful with exponential growth and decay. So first thing is you need to how to know to go from decimal to percent. So to go from decimal to percent, you move the decimal twice or times by 100. So if you were to move that decimal point twice, the decimal is now here. You do fill in zeros if there are spaces. So 0.2 is the same as 20%, okay? So how do you go from percent to decimal? Then you move the decimal 2 spaces to the left or divide by 100. So now if you move your decimal there, 55% is 0.55. How do you write 10% as a fraction? First, you need to go to a decimal form, which is 0.1. So 10% is the same as 1/10. Okay. These two are the main, most common ways from going from decimal to percent and percent to decimal. So let's take a look at the notes first. Okay. So the first thing, in previous lessons, we learned that exponential functions, the variable is in the exponent. We also learned that the function is always increasing or decreasing, and it's not at a constant rate. So it's going up really quickly or it's going down really quickly, but not at the same constant rate. So in this lesson, we're going to learn to identify exponential growth and decay, and then we're going to identify growth factor, initial value, and rate. So first off, let's look at some functions. Let's look at some graphs. So to graph an exponential function, you can either type it in your calculator into y equals, and you would type this in and make sure you raised it to the x, or we can graph it by hand because 1 is my initial value. So I would start at a 1, and then 2 is my growth factor or my base. So I'm timesing by 2 each time. So 1 times 2 is a 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16, and that's kind of all I can do. So if I connect this graph, remember it's not going to go past 0. And so that's what the graph of that function would look like. Let's look at number 2. Again, you can type in your calculator, or that's your initial value and that's your growth factor. So I'm going to start at a 2 now. And my factor is 3. So I need to times by 3. So 2 times 3 is 6. So I'm going to go to a 6. 6 times 2 is 12. So I'm going to go up to 12. 12 times 2 is 24, and that's off the graph. So I'm going to stop here and go ahead and draw and connect my points. Okay? So let's talk about this bottom question. It says, what do you notice about the two graphs? Well, I notice that they're both increasing. They're both going up. Okay, so those both graphs were increasing. Okay, that is all. So let's turn the page and do the next one. So now we're going to graph something with a fraction. How we do that is, again, you can graph it in your calculator or you can do it by hand. So I would go to a 1 because that's my starting point. And then I need to go backwards because they were dividing. So I'm going to times by 2 and go backwards. So I would get 2 here. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Okay? So if it is a fraction, you are kind of going the opposite way. Like that. 0.4 looks a little tricky, so I'm just going to graph that in the calculator. If you graph it in the calculator, you end up getting something like this. Something like that. Okay. So compare equations 1 and 2 with 3 and 4. So here were equations 1 and 2. They are both going up. Equations 3 and 4 were both going down. So 1 and 2 were increasing, and 3 and 4 were decreasing. Okay, and that is because the number in the parentheses. So if I look back here at 1 and 2, 1 and 2 had a number, like a whole number, whereas 3 and 4 had fractions and decimals. So we're going to learn a little bit about that right here. So let's see when it's growth and when it's decay. So when A is greater than 0, so you're always going to have an initial value bigger than 0, and your B, which is the number in parentheses, is greater than 1, it's going to be increasing, so it's going to be growth. Okay? For decay, if you have, again, A always has to be greater than 0, and A is your initial value. If B is less than 1 and greater than 0, so it's never going to be negative, it's just always going to be smaller than 1. That is going to mean it's decreasing and it is a decay function. Okay? So again, the number in parentheses is never going to be negative, it's always going to be positive. If it's a fraction that is smaller than 1, it is decay. If it is a whole number, so it's bigger than 1, it's going to be growth. So let's take a look at some practice examples. So tell whether these graphs are growth or decay. So A is going to be decay because it is decreasing, and that means B is going to be a growth, exponential growth, because it is increasing. And then let's take a look at these examples down here. So notice I'm only going to look in the parentheses to determine if it's growth or decay. I want you to type 3 divided by 2 in the calculator. You're going to end up getting 1.5, and 1.5 is bigger than 1, so it is growth. So it's an exponential growth problem. So just because you see a fraction doesn't mean you can say, hey, it's a decay because it's a fraction. You have to make sure that fraction is bigger than 1 to be growth. Same thing over here, so 1.2 is bigger than 1. So that is going to be growth because it was greater than 1. Same thing over there, greater than 1. If there is no number in parentheses, that means you have an assumed initial value of a 1. So your growth is still a 2. So that is going to be a exponential growth function because 2 is bigger than 1. If you were to type 1/4 in your calculator, you would get 0.25. And since 0.25 is smaller than 1, that is going to be exponential decay. Same thing over here, 0.5 is smaller than 1, so that is going to be exponential decay. Okay? The last example, it wants you to give your own 2 examples. So here are some examples of exponential growth and decay. I don't care what my initial value is, but I do need to make sure the number in parentheses is bigger than 1. So I could say 4. And make sure you raise it to the x power. Another example, again, the number out front can be whatever you want. It's okay if it's decimal. You just need to make sure the number in parentheses is bigger than 1. So we can say like 1.5 and raise it to an x power. For exponential decay, again, you do not care about the number in front, so it could be 3. I just need to make sure the number in parentheses is smaller than 1. So I could say 0.2 and raise it to the x. Again, for another example, I can make the starting point 0.7 because that's okay. And then we could do maybe 3/5 in the calculator because that's smaller than 1. Okay? So those are how you tell whether something is exponential growth or exponential decay. Okay, the next page is on parts of an exponential function. So remember, A is your initial value. If B is bigger than 1, that means it's going to be a growth. It's an exponential growth function. So B is your growth factor. And then the growth rate stands for R. And to find the rate, you're going to do your growth factor minus 1 because you want to see how far away from 1 the number is. Okay, so for example, if it's a growth, that means maybe you would have a growth factor of a 3, which means to find your rate, you would do 3 minus 1 and get 2 for the rate. Okay, so to find the rate, you're always going to subtract 1. So let me write that instead. Subtract 1. Okay. For exponential decay, you know for decay, A just is your initial value. B is if B is, that should be less than. So if B is less than 1, that's going to mean it's a decay problem. And then B is going to be your decay factor. So that means R is your decay rate. And in this case, you're going to do 1 minus B instead of B minus 1. So for example, let's say your decay factor was 0.7. Okay, so to find the rate, you're going to do 1 minus 0.7 to get 0.3 for the rate. So you're basically seeing either how far it was away from 1 for this problem. So 3 was 2 away from 1, and then this was 0.3 away from 1. Okay, so let's take a look at some examples. All right, so looking at this problem, I need to figure out if it is decay or growth. So to do that, I'm going to look at the number in parentheses. 1.8 is bigger than 1, so that is going to be a growth problem. Okay. To find the initial value, that's going to be the number outside of the parentheses, so the initial value was a 3. The whole number in the parentheses is your growth factor, so it's going to be your growth factor, so it's not decay. And then again, to find the growth rate, you're going to do 1 minus or it minus 1. So you would do 1.8 subtract 1, because you will always do the bigger number minus the smaller number. So maybe that will help you all out. And then 1.8 minus 1 is just 0.8. So our decay rate is going to be 0.8. You can also make that a percentage by moving the decimal twice and getting 80%. So you can either say 80% or 0.8 is your rate. Okay, we usually do percentages. Let's look at number 2. So in number 2, again, I look in my parentheses to determine if it is a growth or decay. That number is bigger than 1, so it is going to be a growth. Your initial value is the number in parentheses or outside the parenthesis. Your growth factor is the whole number in the parentheses. And then to find the rate, so since that number is bigger than 1, I would do 1.04 minus 1 to get 0.04. So you can say 0.04, or we can turn that into a percentage by moving it twice, and so that's the same as 4%. So the rate would be 0.04 or 4%. So let's do one more problem together. Let's look at a decay problem, and then I'll let you try these on your own. So for this problem, 0.8 is smaller than 1, so it would be a decay. Your initial value is a 9. The growth factor is a 0.8, and in this case, 0.8 is smaller, so to find the rate, you would do 1 minus 0.8 and get 0.2. Again, we can turn 0.2 into a percent, and that's the same as 20%. So now I want you to try numbers 4 through 8, as well as finish this whole packet for practice. The answers are with me, so I have an answer key if you need it. Thank you for watching Exponential Growth and Decay Function.